Hello, welcome back to Cinderella Math. Today we'll be doing, I'm going to give you one root of the function, and we're going to use that to find all the roots, or the zeros, whatever you call them. Roots, zeros, solutions, they all mean the same thing. This is most likely a pre-calculus topic. Maybe could see it in an advanced algebra 2, but I'll probably label it pre-calculus in that area there. Alrighty, so let's get started. Here's my example 1. And we have the polynomial f of x is 2x cubed plus 3x squared plus 50x plus 75. And we are given that the first root, or zero, is 5i. Alrighty, so you do need knowledge of imaginary numbers before doing this. So if that's not your jam yet, I'm sure I have another video on imaginary numbers, so feel free to check that out first. All right, so we do know that imaginary roots always come in pairs, conjugate pairs. So if 5i is an answer, then his conjugate buddy, negative 5i, will also be an answer. So that's great. We can just automatically know that. That's just a rule that they come in pairs. And then if you look at the original function, we do have a cubic. So that means we're looking for 3 roots, 3 zeros, 3 solutions. So we have 2. So we're just missing that third one. All right, so the 2 answers we have, if you set them equal to x, that would be x equals 5i and x equals negative 5i. Go ahead and reverse it, like make it look like a factor. So move this over. That would be x minus 5i. Move this over. That would be x plus 5i. So those are 2 factors of this third degree or cubic polynomial. And now we're going to go ahead and FOIL that out to get a quadratic. And then we can do division. So x times x is x squared. That would be positive 5ix, negative 5ix, negative 25i squared, but we know that I squared is negative 1. And again, that comes from the definition of I. I is root negative 1. So I squared would be root negative 1 squared, which is negative 1. So the middle cancels, right? Positive 5ix minus 5ix, bye-bye. And we're left with x squared minus minus is plus 25. Alrighty. Now what? That is our quadratic factor. And if we take the original function, divide that quadratic factor, and I'm thinking like long division here. All right, I'm going to cover that up for a second. So let's take the original function, divide that quadratic factor we just got, and whatever comes out should be our last factor. X squared would be a 2x. Distribute, that'd be 2x cubed. And that would be no x squareds and 50x. Subtract, this is gone, this is gone. Drop down, drop down. We need to know how many times x squared goes into 3x squared, so that would be 3. Distribute, distribute. Subtract, cancel, cancel, remainder 0. So here is our last factor, but they want the 0. So let's set that to 0. I'm sorry, I'm running out of room. I'm going to just go up on top of this. So we take that factor, 2x plus 3, set to 0. And we have it, negative 3/2. So our final zeros of this cubic polynomial is 5i. That was given. Then from that, we got the negative 5i, because those always come in conjugate pairs. And then we solved out, did some work there, and we finally got the last 0 of -3/2. Answer. Now, that might have been the long way around the bend on that one. Same problem. Again, you would look at what's given. We were told 5i, so we immediately get the other factor of, excuse me, the other 0 of -5i. But if we come over to that original function, it is 4 terms, so we could maybe try to factor this by grouping. Let's see. Now, this may not always work, but let's give it a try. GCF out of the first set would be x squared, leaving 2x plus 3. GCF, or greatest common factor, out of the second set would be 25, leaving us 2x plus 3. So now that's x squared plus 25. We put the lonely stuff together, and then we drop down the other one. All righty, now set to 0, set to 0. This one would be, there's our -3/2. And this one, x squared is -25, root x is plus or minus 5i. So that was probably faster, but this grouping doesn't always work, right? That's kind of a fluke that it worked on that one. So that's why I wanted to show you kind of the long way too, because sometimes we will have to go, like must go the long way. All right. That was a cubic. I will do one more cubic and then I'll try to get into a 4th degree. Here's example 2. It will also be a cubic here. I've got x cubed, or it's a function, x cubed minus 7x squared minus x plus 87. And we are told that we have a 0 of 5 plus 2i. So that means immediately we get another 0 of its conjugate. So we get 5 minus 2i. Basically, buy one, get one free, if you will. Okay? Now this time, again, we need 3 answers. Because it's a cubic, we've already got 2. Let's try the grouping thing first, because if that works, that's certainly the faster way to go. So if we put these in a group and we put these in a group, GCF, GCF, that doesn't work, right? For grouping to work, this has to match this. The leftovers have to match. So this time, the grouping thing does not save us any time because it doesn't work. This cannot be factored by grouping. So we are going to have to go the long way. It's okay, still doable. So if you say this is our 0, that's really x equals 5 plus 2i. And then the other one would be x equal 5 minus 2i. Kind of reverse those to get them back into like factor form. So this is going to come over and be x minus 5 plus 2i. And you're going to leave it in parentheses. You're going to do a double parentheses situation. I know that looks horrible. I'm sorry. And do the same way with the other one. So this will be x minus 5 minus 2i. And again, just it's going to look like a hot potato, nasty, double parenthesis situation. And now go ahead and FOIL that out to get it's going to be a quadratic, right? Because x times x will be x squared. This will be x times, so negative x really, times that parenthesis. And then under, that'll be negative x times the other parenthesis. And then under, negative times negative, so positive parenthesis times parenthesis. Okay? Distribute and FOIL again. So x squared minus 5x plus 2ix minus 5x minus 2ix 25 minus 10i plus 10i minus 4i squared. All right, let's see what we got here. Ooh, let's see, x squared minus 5, so we're looking at minus 10x Positive 2ix minus 2ix, that cancels. Negative 10i, positive 10i, that cancels. The I square is really negative 1. So that's 25, and then minus minus, that would really be plus 4. 25 plus 4 is 29. There we go. So there is our quadratic factor. All right, now I'm going to have to go on top of this, so pause me if you're still working with me there. Let's take the original function, divide that quadratic factor. All right. How many times does x squared go into x cubed? X. Distribute, that would be x cubed minus 10x squared, positive 29x, and subtract. This is gone. Minus, minus, this is really going to turn to plus, negative 7 plus 10, so 3x squared. Negative 1 minus 29, so negative 30x, and drop down. Okay, how many times does x squared go into 3x squared? 3. Distribute, so that's 3x squared minus 30x plus 87. Subtract, this will cancel. This turns to plus, which will cancel, and this will cancel. Remainder 0. Here is our linear factor. Set that puppy to 0, and x is negative 3, giving us final answers here. We have 1 real root and 2 imaginaries. Alrighty. So I've done 2 cubics. I'd like to do a 4th degree. Okay, example 3. The function is 2x to the 4th minus x cubed plus 7x squared minus 4x minus 4, and the given 0 or root is 2i. So automatically we get his partner negative 2i. Now that grouping trick that worked on number 1, we can't group here, right? Because we don't have 4 things. We have 5 things. So that's off the table. So we will have to go kind of the long way. But hey, we've got 2 answers and we need 4. So we've got half, that's a good start. So again, what we do is we say x really equals 2i and x really equals negative 2i. Reverse that to be a factor of x minus 2i and a factor of x plus 2i. Go ahead and FOIL that out. X squared plus 2ix minus 2ix minus 4i squared, which is really negative 1. Negative 4 times negative 1 is really plus 4. These cancel, and we get x squared plus 4. There's our quadratic factor that came from the given information. Now we're going to take the original function and divide by that quadratic factor. How many times does x squared go into 2x to the 4th? 2x squared. So that would be 2x to the 4th plus 8x squared. Subtract, this is gone. Drop down, drop down, drop down. All right. How many times does x squared go into negative x cubed, negative x? Subtract, this will turn to plus, cancel, drop down. This will turn to plus and cancel, drop down. How many times does x squared go into negative x squared? Negative 1. Distribute, subtract, this will turn to plus and cancel, remainder 0. This is our next factor, which is also a quadratic factor, which makes sense because it's x to the 4th. Okay, I'm going to have to white out a whole bunch of stuff here, so pause me if you need to. We have this quadratic factor now of 2x squared minus x minus 1. Let's see if that factors. I factor with the magic x method. So this is -2, -1, the middle number. Multiply here, add here. What if we did -2 times 1? That would multiply to -2 and add to -1. So, see this x squared? 1 for you, 1 for me. And we had magic numbers of a -2 and a +1. But when this front number a is anything other than 1, this multiplication is kind of cheating. So I'm going to divide to undo that, giving us x minus 1 and x plus a half. Set to 0, that would be -half. Set to 0, and that would be 1. So we have done it. We have our 4 answers, the zeros of this 4th degree function. 2i was given to us, which automatically gave us -2i, because those come in conjugate pairs. And then after all that algebra, we got 1 and -half. Alrighty, I think that might be where I want to just go ahead and call this a day. So this was using a given 0 to then find all the zeros of a function. Not the easiest thing in the world, but once you practice and get the hang of it, you can do it. Just always remember the i's come in those conjugate pairs. Watch your signs, watch your algebra. You got this. I hope that was helpful, and I'll be back with you soon. Bye-bye.